Welcome to the debate. Our focus today is on purple teaming, the critical strategy of unifying offensive or red team capabilities with defensive blue team capabilities. This integration is now, well, it's widely accepted as essential for building modern resilience in the face of today's complex threats.
Indeed. And it really marks a profound transformation, I think. We're moving security testing away from these isolated sort of one-off exercises and toward a much more collaborative and continuous practice. It shifts the entire operation from being reactive to proactively assuring system safety.
So the central question we're wrestling with here is this: what is the primary, the most effective driver of measurable security improvement in a mature purple team program? I'm going to argue that true, scalable, and durable improvement comes from rigorous, automated, metrics-driven validation. This capability is enabled by integrated tool chains and platforms, your CALDERA environments, your SIEM systems, your SOAR orchestration. It is the only way to generate objective evidence.
And I come at it from a different angle. While, the necessity of automation to achieve scale is undeniable, I maintain that the foundational, human-centric cultural and organizational shift is the true primary driver. Things like transparency, knowledge transfer, cross-training, these must be deeply established first. Why? Because that cultural base is what ensures the automated systems are testing the right things, and critically, that human analysts can successfully interpret and act upon the flood of data those systems produce.
Okay, so let's start with the hard reality of scale. Measurable resilience in today's complex, dynamic environments, where configuration drift is a constant and systems change daily, is simply impossible without automation. Relying on manual efforts, well, that inevitably leads to inconsistent results, to gaps in coverage, and critically, slow feedback loops. The security cycle we're all striving for, the one focused on continuous improvement, it absolutely demands automated orchestration. This isn't optional, it's fundamental. This orchestration was what allows us to run repeatable threat scenarios with total consistency, collect uniform telemetry, and compute objective, measurable metrics. We're talking about core indicators like time to detect and false positive rates, and specific tooling like the MITRE CALDERA framework or other adversary emulation platforms. They are the vehicles for this transformation. They provide the only practical path to what we call continuous validation. And this is necessary precisely because it can catch critical regressions caused by a simple patch or a change in a firewall policy. We have to embrace the idea that security detection is a code discipline, where every single rule is unit tested against real adversary emulation. The rigor comes from the machine.
I appreciate the focus on engineering rigor, I really do. But I think that perspective fundamentally misreads the foundational issues that purple teaming was designed to solve in the first place. Automation is just an accelerator. It cannot and it will not compensate for fundamentally flawed, noisy detection content or, broken processes that nobody follows. The essential high-quality inputs, the collective intelligence about what to test and how to interpret the results, that must be human-derived and culturally embedded. If you look at the origins of this model, the shift to a purple approach was a direct cultural solution. It was designed to overcome the problem of isolated security efforts, where red and blue teams operated in separate silos, gathering only partial fragments of insight. Effective purple teaming requires shared situational awareness.
That isn't a technical configuration. It's built through analysts working side by side, collaboratively reviewing attack traces, and refining response playbooks. You have to define roles and responsibilities to facilitate transparency and mutual respect. If a red team operator doesn't get the nuances of detection engineering, their emulation is just going to generate useless noise. And if a blue team analyst doesn't understand offensive tradecraft, they won't build robust analytics. That collective intelligence, fostered by a culture of trust, is the absolute prerequisite for any actionable metrics. Without it, you're simply measuring how fast your systems process garbage.
I see why you emphasize the human input, but I would argue that the technology provides the essential rigor that the human element often fails to deliver consistently, especially at enterprise scale. The machine validates the effectiveness of detection logic at scale and over time. Let's talk about those metrics. Data streams from automated runs provide objective insight into defensive performance. This is crucial for executive reporting and, for justifying security investments. If you cannot measure time to detect, time to remediate, and coverage continuously and objectively, you cannot prove improvement to stakeholders. And let's be clear, we're talking about translating findings into a sustainable, threat-informed detection engineering program. That process has to be codified. The moment you rely on a manual, context-heavy human review for every single piece of detection logic, you lose the ability to test for regressions. You can validate a rule manually today, sure, but what happens when a new patch introduces a blind spot tomorrow? Automation provides that necessary regression testing across tens of thousands of endpoints, ensuring the stability of that detection logic. I mean, how can any human process possibly keep up with that pace of validation?
That's a compelling argument about regression testing, I'll grant you that. But you're focusing on the quantity of testing over the quality of the artifact being tested. The quality of the analytic it's fundamentally rooted in human context. Take the issue of reducing false positives through purple feedback loops. This isn't just about speed. It requires blue analysts to differentiate the true positive malicious patterns from red's emulation, which might look suspicious, from acceptable but operationally similar administrative activity. That tuning process, identifying those context blind spots and encoding specific exclusions into your detection rules, demands direct, collaborative, side-by-side review between the red and blue analysts. It can't be solved by just an automated pass-fail result dumped into a dashboard. A machine running a test quickly only verifies that the logic can fire. It doesn't verify the rule's fidelity in the messy real world. If the rule is noisy, your automated measurement is just verifying the efficiency of a flaw. So in my view, the human expertise built on that collaborative understanding is what creates the testable, high-fidelity rule in the first place.
Okay, but let's shift the focus to the other half of the security equation, response. Because there, speed is paramount, and I'm not entirely convinced human context is the primary limiter. Tool integration is absolutely vital for response. I mean, integrating the SIEM, the EDR, and a SOAR platform for real-time feedback. This is what ensures that automated containment actions, things like host isolation or terminating a process, execute reliably the instant a detection threshold is met. By designing the automation to check for SOAR case creation, to verify the exact status of the response action, and measure time to containment objectively, what we confirm that our systems can execute decisiveness. This is the definition of shifting from reactive firefighting to proactive assurance. Response validation that relies heavily on manual observation is inherently slow, it's inconsistent. That human latency consumes the time to detect advantage that automation provides us in the first place. You're sacrificing measurable, provable containment speed for procedural nuance.
I see why you prioritize that speed of execution, but response effectiveness is fundamentally a function of human process clarity and readiness. Automation verifies the API call. Fine. It verifies the technology can technically execute. But what about the procedure surrounding the action?
Refining incident response playbooks involves identifying and refining critical decision points and documenting where analysts struggle to find information or confirm scope, for instance, navigating different consoles under pressure. The material stresses the importance of coordinated live exercises. These are essential precisely because they capture synchronous observations that reveal process or training gaps that purely technical metrics like a SOAR script running successfully simply cannot show. An automated playbook execution only verifies the technology. Human observation verifies the procedure, and more importantly, the cognitive readiness of the SOC team.
It's the whole response procedure breaks because an analyst fails to perform a necessary pre-containment validation step because of poor training or confusing documentation. Then your automation failed to prove true resilience. The problem isn't the speed of isolation, it's the analyst's confidence in pressing the button.
That reliance on readiness suggests we are leveraging standardization enough to bypass that organizational friction. I'm just not convinced by the idea that we need continuous human observation when we have powerful standardized frameworks. The successful evolution of purple teaming was driven largely by standardization, which allows us to transcend local cultural variance and get objective metrics. Frameworks like MITRE ATT&CK give red and blue teams a single, unambiguous, unified taxonomy for adversarial behavior. This is a technical requirement for automation. CALDERA needs standardized inputs to run threat-informed emulations. This common language makes results globally comparable and scalable, which fundamentally supersedes local cultural preferences or training issues. If the entire organization operates under a unified taxonomy that's enforced by tooling, the engineering discipline takes priority over the complexity of team dynamics. We standardize to reduce the reliance on that localized expertise.
But standardization is inert without the cultural shift that enables transparency and trust. You can mandate the use of Attack Navigator and a unified taxonomy, sure, but if the culture is punitive, if leaders use metrics to judge failure rather than drive improvement, the analyst will game the system. I mean, think of the practical challenge. If the red team knows that exposing a critical, long-standing detection gap will get the blue team reprimanded, they might subtly sandbag their results. They might pull their punches to preserve team harmony. And likewise, if blue team analysts fear exposing their own blind spots, they will hide or minimize the data, rendering your automated metrics meaningless. That organizational buy-in, the shift that replaces blame with collaboration, is the prerequisite that prevents these human biases from sabotaging your objective data. Technology can't measure the fear of failure, but that fear is what determines the truthfulness of the data you feed the machine.
And that brings us back to the definition of maturity. While I fully agree that cultural foundations are necessary to even start the conversation, to build that initial trust, the long-term, scalable, and durable state of modern security resilience is achieved through engineering discipline. The tools enforce the honesty you require. Automated toolchains, from high-fidelity CALDERA emulation runs generating precise data streams, to rapid, verifiable SOAR response, provide the measurable evidence, the continuous regression testing, and the repeatable feedback loops necessary to build a truly adaptive security capability. This capability can demonstrably keep pace with the evolving threat landscape. The technology provides the quantitative objective proof of resilience that validates the entire program. Human collaboration gets you off the ground. Automation ensures you stay in the air.
The problem is that the technological engine's output is only as effective as the fuel it receives. The effectiveness of the machine is determined entirely by the quality of the human input and the environment that input operates in. Cultural transparency, a robust organizational structure, mandatory cross-training, the collaborative review of live exercises, these are what ensure that detection content is high quality, that playbooks are actionable, and that the resulting metrics reflect meaningful risk reduction. If those inputs are faulty, if the rules are noisy, if the procedures are broken, the machine just executes a faulty process faster. The human element provides the critical intellectual clarity and context necessary for any effective, high-fidelity integration.
Well, I think this debate really highlights that purple teaming is truly a convergence, where people, process, and technology have to align perfectly. It's clear that true success depends on achieving both cultural maturity and engineering discipline. Neglecting one in favor of the other severely limits an organization's ability to achieve true resilience. Thank you for walking through these essential distinctions.